Now we have two samples. It's x1 bar is 14, S1 2.2, and N1, the sample size is 18. It's a sample number 1. And the sample number 2, x2 bar, that is a 16, S2 2.1, and the sample size from sample 2 is another 18. So now we have 18 and 18. It asks us two-tailed test. Okay, so step number 1, always the null hypothesis can be stated as mu1 is equal to mu2, always. And this problem asks us is apply the two-tailed test. That means it's not equal to. So simply we state alternative hypothesis is not equal to. They are different. So later we are going to take one tail probability, the right tail or left tail, then simply just take twice because it is a two-tailed. Yeah. So now let me take the test statistic. To take the test statistic, before the test statistic, we need the SP, the pooled standard deviation. The SP was square root of N1 minus 1 S1 square, N2 minus 1 S2 square, N1 plus N2 minus 2. So now it will be 18 minus 1, that will be 17, times 2.2 square, plus it's another 18 minus 1 times 2.1 square, over 18 minus 2. So can you give me the numerator, please? Yeah, using your calculator. 17 times 2.2 square plus is another 17 times 2.1 square. So please give me the numerator first. I didn't bring my calculator, so please let me know how much will be the numerator. Say again? 157.25. And denominator will be 18, 36 minus 2 will be 34. Then can you give me the ratio inside of the square root? 157.25 divided by 34. 625. Then now please take the square root of it. Two point one five. 2.15 will be the pooled standard deviation. It is not a test statistic. Yeah. Now we have to take the t-score, the test statistic, which was the sample mean difference, SP, 1 over N1 plus 1 over N2. So now take the difference between the two sample means. It says 14 minus 16, that will be negative 2. And plug the SP we got is a 2.15 times 1 over 18 plus 1 over 18. Please give me the denominator. 0.716.
717.
Second, 0.717. And how much will be the t-score finally? Negative 2.79. That is a t-score. That will be the test statistic. Okay, now let me take the p-value from the t-distribution. So step number 3, from the t-distribution, mean equals 0. How many degree of freedom? The degree of freedom was here 34. And now the test statistic is a negative 2.79. We need the left end. So please go to the menu in your calculator to get the probability. And you select TCDF. The lower is a negative 9,999. It's a negative infinity. Up to negative 2.79 with the degree of freedom 34. Can you understand how can you input the numbers into your calculator to get the left tail probability from negative infinity up to negative 2.79 with the degree of freedom 34? So how much will be the probability? How much is the left tail probability? Point 0.0040.
4289.
283.
289.
Yeah,
4289.
428. Yes, it's 43. Yeah, I need the 4 decimals. Yeah. But it was two-tailed. So the p-value we have to take twice. 0.0043 times 2. So the p-value will be 0.0086. In the problem, alpha was 1%. So now we have to make the decision. 1%. 1% is a 0.01. Absolutely, even we took the twice, the p-value is much smaller than 1%. P-value is less than alpha. Reject the null hypothesis. Because p-value less than 1%. Alpha. So now reject. Now reject the null hypothesis. We have to make the conclusion based on what? Alternative statement, which said they are different. I don't know what is the problem exactly, this one, but when we compare the two population means, 14, 16, there is only the difference 2, but it is big enough because the denominator, relatively, the standard error is very small. It's smaller than 1. So the difference 2 is big enough. So because of that, we got a very small p-value, even we took twice. Finally, less than 1% alpha, we should reject the null hypothesis. So the conclusion must be they are different. I don't know who they are, but they are the two unknown population mean as a mu1 and mu2 in the two populations. They are different.